Okay, so we are officially on session 4 of session 5, and I tell you what, folks, it's been a great journey. It's going to be emotional on Thursday when we wrap it up on the Ultimate Edition, when we do the full workflow. But yeah, and again, these recording sessions will be available for you. And as I mentioned, we're on the 4th session, which is BricsCAD Mechanical. And, for those folks who are coming from the previous sessions, we thank you for joining back in. I can see a lot of names there that we recognize from session 1, 2, and 3. It's always difficult straight after the Easter holiday, a webinar, but it's a great way to, warm yourself back into business. It really is. And again, for those who are joining fresh today, rest assured what you'll see today in BricsCAD Mechanical, you do get everything from session 1 and 2, BricsCAD Lite and Pro, in Mechanical as well. Very important about that. So today, we really want to introduce you to the BricsCAD Mechanical, which, in my opinion, is a unique, flexible approach to mechanical design, providing advanced solutions for manufacturers out there. Okay, so your host today are the talented Frederick from Belgium. There he is, a great guy. If you ever get a chance to get in Ghent, absolutely. What he doesn't know about mechanical is not worth knowing. Absolutely great guy. And myself from the UK. And what we'll do, we'll kick this off now. And I'll just very quickly just turn my camera off. And I say this all the time. As I said, as folks could be joining in. BricsCAD is unique. It's innovative. It's cost effective. Most important, it's DWG-based CAD platform. And it's a light application. It's still surprising me, under 500 megabytes, that you can download a full version of BricsCAD, and off you go. That is yours to use on a trial, which will come to shortly. So, we do offer BricsCAD. It does offer you 2D CAD for fast and efficient drafting, fully based on the industry standard DWG. It also, for those folks who joined us on session 2, but not just 2D, but it gives you that punch, to 3D CAD to really help you solve design problems much faster than you're currently using. And of course, what today's session is going to be about is advanced intelligent mechanical design tools. Enables greater design freedom. And of course, the previous session, which was session 3, which was all about BIM, we have a different approach to building information modeling. And I really implore you guys, for those who missed that session, check it out. It's what we call BIM for CAD users. It's as simple as that. Really great session. Okay, so the power of BricsCAD Lite, Pro, BIM, and Mechanical in one convenient package. That's BricsCAD Ultimate. Again, one application based on DWG, and you're not changing applications. You just change environment. So you could be doing some concept stuff in the free BricsCAD shape. By the way, folks, every version of BricsCAD gets shape for free. What shape? It's a bit like SketchUp. It's intuitive pull function concept modeler, and you get that free. You can download a BricsCAD Ultimate trial for 30 days. That's yours to do whatever you need to do. And one of my team colleagues will put that link in the chat window. So check that out right now. And as I said before, we've got the team here at Bricsys. Please use the Q&A session to ask any questions you've got on BricsCAD. That's what we're here for. Okay, so let's get started. I briefly, mentioned Bricsys, but who are we? Bricsys is the company that makes BricsCAD. It is a global provider of affordable modern CAD, BIM, MCAD, mechanical CAD, and CDE, common data environments. Brought to market under the BricsCAD and Bricsys 24/7 brand. We are part of Hexagon AB, and in my opinion, BricsCAD is our best kept CAD secret, and that's changing. As new customers are embracing BricsCAD now with over 300,000 active users in over 110 countries, and that number is growing at a very fast rate. I kid you not. Just UK, as we were one of the best years last year. EMEA had its best year last year, and it's going from strength to strength. And this is purely, it doesn't matter who you are as an architect, surveyor, engineer, designer, interior designer. If you're using CAD, you seriously want to look at BricsCAD. Not only is it easy and light, which is great for IT, by the way, easy to use, but it's cost. The costs are so attractive. It's unbelievable. And plus, the license option that I'll talk about a bit later on. So it's great. And talking about all these customers who have embraced BricsCAD, we do service various types of industries across the globe, and that footprint is expanding. And you can see from this slide, like Mazda, Hyundai, Bosch, BAM, they are all enjoying the fruits of BricsCAD, and it's a great place to be. Okay, so today's session, as I mentioned, is mechanical. Now, interesting enough, I started off in AutoCAD in industry, but then I went to various different 3D mechanical softwares, and it is a sweet spot for me, and I do like mechanical. But I tell you what I like even more is BricsCAD Mechanical, because if you're already familiar with BricsCAD Core, BricsCAD Lite and BricsCAD Pro, which was in session 1 and 2, and you already know how they offer you flexible, intelligent tools to address many needs of manufacturers today and designers. But if you need more advanced requirements such as complex assemblies, sheet metal, piping design, you really need to check out what BricsCAD Mechanical offers. Firstly, it makes mechanical design accessible. It provides the optimum tool set at the realist price point. And it's all based on DWG with a familiar look and feel. It makes the move from 2D to 3D to mechanical design so much easier for anyone using legacy CAD tools. It also enables design freedom, providing flexibility in how you work. And as part of the all-in-one BricsCAD design platform, you can take advantage of a seamless workflow across disciplines such as BIM to fabrication. Now, we are, with BricsCAD, I've mentioned in the previous sessions, the lights, the pros, and even in BIM, BricsCAD Mechanical continues the Brics' philosophy of providing AI-powered intelligent tools to speed up your design workflow. It really does. And provides the flexibility to design the way you want to, okay? Whilst remaining highly compatible with legacy DWG-based CAD solution. Now, on top of this, it offers a set of powerful advanced mechanical design capabilities, but remains far more affordable than the dedicated mechanical design products. I could name 4 or 5 just top of my head. I'm talking about MCAD, not AutoCAD. I'm talking about your Solid Edge, your SolidWorks, your Inventors. I've used them all. And I kid you not, depending what you're using, if you're using it for 3D concept products, maybe sheet metal, bit of mechanical design, bill of materials, all that good stuff. I kid you not, you can do all that with BricsCAD Mechanical. And it's so intuitive. It's seriously, check it out. It is a lot. And also our 3D modular, by the way, it is a direct modular. So you're not kind of restricted to the history base, but when you want to, you can put parametrics on there to kind of control that for you as well. So we give you the best of both worlds. So let's take a deeper dive on those 3 areas on the right-hand side of the slide. So the first one is flexible 3D modeling, what we call the powerful direct modeling approach in BricsCAD. Our unique 3D design approach combines dynamic and interactive direct modeling with ability to add parameters only when they need it. And that's very important, when they are needed. Go in, be creative, pull functions, do all that good stuff. Once you're happy, lock them down, put your parameters in when they're needed. And this is great because this is without the complexity of a history-based approach. So, I've come from both background, history-free and history-based, and this really does give you the best of both worlds. It really does. It's as simple as that. And of course, another sweet spot of mine is sheet metal. I started off as a sheet metal fabricator using AutoCAD. And I remember those days when I would have to work at the K factors, the bend allowance on a 2mm gauge. And I couldn't grasp the fact that when something gets bent, yeah, and you got a couple of folds in there. When I need to cut that out on a plasma or a laser or a water jet, if we're ever so lucky, the material is going to stretch, it's going to grow and decrease in certain areas. You're going to take this into effect, and doing this in 2D was a nightmare. You got all this covered in sheet metal in BricsCAD. You can create sheet metal parts, designs that are resilient and are deeply editable. Import or create from scratch. Bring a 2D geometry or bring a 3D geometry. It's your choice. Not only does BricsCAD Mechanical let you create sheet metal components from scratch, but you can also convert solid parts to sheet metal automatically with just one click. It is, yeah, albeit in a lot of 3D applications kind of do this. But when you take in the fact with our price tag, the flexible licenses, that all in one, not many can do that. And again, when we moved from industry, we swapped a couple of seats of AutoCAD. We moved to a certain 3D package, but we kept some of the AutoCAD because the look and feel of the documentation, with all our scripts and templates running in the background, were required. You don't need to worry about that with BricsCAD. You've got it all. This is the beauty of it. You really, really do need to check it. Check out that trial, folks. It really is a great stuff. Create a sheet metal component. You can run scripts. You can have a template set up. Boom. There's your drafting. There's your detailed 2D drawing of a flapped pattern, a blank size to send to a plasma to cut, for example, with a bend table, your bend allowances, your K-factor, all taken care of. It's all sorted in the background. Really great stuff. Okay. And again, because of time, we're only scratching the surface of BricsCAD Mechanical. We really are. The other element I want to talk about is mechanical assembly, bottom up and top down assembly. Again, I used to love doing this. I started off as a bottom up, bit like Lego, where you design one part, save it, design another part, save it, start a new assembly, bring them in one by one and build it up. Top down, which is a great way, when you've got your assembly, you can design in context of assembly to make sure fit and function and interference, all that good stuff, all that's available. Okay, so BricsCAD Mechanical, users can create the complex hierarchies of parts and sub-assemblies using bottom-up or top-down design methods. You can import assemblies from different CAD systems, not just parts, but from different CAD systems, these assemblies using the communicator for BricsCAD, including parametric geometry defined in those assemblies as well. You don't lose anything. And our open approach means it provides a mechanical design engine on which great solutions can be built. It really is, amazing. Seriously, when I looked at the 2D offering that we have, but those folks, okay, well, I come from an AutoCAD. I used to design bridges for a company many, many moons ago. We used to use AutoCAD. I then moved to another 3D application, totally different. And for those folks who were moving from 2D to 3D, it was difficult. Okay, from AutoCAD, the obvious choice we thought was Inventor. Totally different application. No one told us that we have to start again and do this. But in BricsCAD, 2D, 3D, mechanical design, I'll even throw BIM in there now as well, because we covered that session just before the Easter break. It's one application. The learning curve is down. It is really low based on DWG. And BricsCAD Mechanical is affordable, just like Lighten Pro. You can have it for subscription price, a low entry, great for budgeting, £840. That's the latest and the greatest version of BricsCAD Mechanical. That is the price. If you want to own your software, buy once and own it forever, just over £1,500, and that's yours. And by the way, the last time I checked for something like Inventor or something, it's just over $2,500 on subscription. That's a perpetual price. There's the subscription price. I'm telling you, and again, it's that all-in-one application, 2D, 3D, mechanical design. Okay. And the best bit is, which I haven't mentioned, is flexible licensing. All that's built in as well. So again, we have got a lot to cover, and I think it's not fair if I take all the thunder. I know Frederick is eager to jump on. It really is, and we'll see how we get on with time and how much Frederick can show. But we've got a great demonstration for you folks. Again, please use the chat window. Let us know how you're feeling. Let us know if you've got any questions. Use the Q&A tab. If you want more information, click on that little button at the top. But what I'll do now, I'm going to stop sharing my presentation and I will just hand it over to Frederick. And there we are. Frederick, it's all yours, my friend.
Thank you, Jazz. Hello, everyone. My name is Frederick Gundersen, and like Jazz previously mentioned, I am a mechanical product specialist based in the BricsCAD headquarters in Ghent, Belgium. Today, I will be demonstrating the BricsCAD Mechanical product. I will be taking you through somewhat of a typical engineer's workflow, and throughout this workflow, I will show some of the great features that BricsCAD Mechanical has to offer. Here you can see the BricsCAD launch window. Here we can already decide what workspace we want to start with. As you might know or might not know, BricsCAD is one software, but different licensing levels allow you different tool sets essentially and different workspaces to work with. So as all of these different workspaces are in the same software, you will launch the same software, but you will already now decide what workspace and what tool sets you want to work with. So for example, 2D drafting for 2D sketching tools and so on, 3D modeling for extruding and direct modeling tools as we offer, as well as some parametric modeling functionality. Mechanical design, which is angled more towards adding mechanical information to your models and so on, some things we will see later on today. And BIM, which is more angled toward architectural purposes, so building information modeling. You can see that the BIM workspace is grayed out. This is because I am now running a mechanical license, meaning that, of course, the mechanical design workspace is enabled, as well as the 3D modeling and 2D drafting. This is because in the mechanical license, you also get the functionality of the Light and Pro product as well. So I will go ahead and launch the mechanical design workspace, and shortly you will see BricsCAD start page. If you have followed our previous webinars for the Light and Pro products, you will be familiar with the start page. So I will not be going too much into detail here, but this is where you can start a new drawing from scratch. You can select different templates to start your drawing with. You can open existing drawings through a file browser, and you can see recent projects as well. Here you can see some thumbnails of the files we are going to work on today, as a matter of fact. On the left side, you can see some different tabs. Currently, this is the Home tab, but we also have a Learn tab for learning resources and test models that you can download, as well as an Application tab where you can access third-party applications to expand on your BricsCAD toolset. So feel free to explore those if you wish. But now I will just go ahead and start a new drawing using this mechanical millimeter template. And I am also in the mechanical workspace, as we can see on the bottom of my screen in the status bar, as we call it. This is my current workspace. If I right-click it, I can switch to any of the other workspaces immediately, because like I mentioned, everything is the same software. It just depends on your licensing level, what you are able to access here. But like I said, I'll start a new drawing. And here we can see the mechanical user interface. On the top of my screen, you can see we have a ribbon with a different set of tools. The Home tab will have some general collection of tools in different aspects, but we also have some tabs for more specialized purposes. For example, some unique tools that BricsCAD Mechanical offers are the sheet metal modeling tools. They are quite impressive tools that will be very interesting if you want to do sheet metal modeling. We also have an assembly tab. BricsCAD Mechanical allows you to generate and constrain assemblies consisting of different parts, blocks, components, as we will see a bit later on as well. We also have some more general things such as settings, different view options, annotating for generating 2D drawings, You will take a quick look at that later also. But you will also notice we have a tab for surfaces, solids, and sketching. So I mentioned that BricsCAD Mechanical includes the functionality of the light license, so the 2D drafting, and the 3D modeling from Pro. And these things lay the foundation of a mechanical design process in a sense. You can take sketches that you draw, and you can then extrude them into solids. And so you have different tool sets for these purposes where you can then elaborate your designs and so on. Then when you have a design that you have created that is a 3D solid, you can then use some of the mechanical unique tools, and you can elaborate the designs by applying mechanical information and use them in a assembly context, which we will get to shortly. As a matter of fact, I can open up an assembly right away. So I have this file here called a pump module. Here you will see an example of an assembly and what it can look like in BricsCAD Mechanical. You can see there are different 3D models put together and constrained together to form this assembly. We can rotate it and take a look at the different parts. And upon further inspection, we can see that this is actually an incomplete assembly. You can see the connection between the pump here and these two tubes is not finished. So we will be using this assembly as an example today, and we will be finishing this design. So you can see that there are some missing parts. So let's go ahead and make these parts. I can first open up this reference here. You can see if I just hover over it, I have this little quad menu that can prompt me to select different options relevant for this scenario. You will see me use this quad later on as well, but essentially this uses machine learning to analyze what you have selected, what the user typically will use in different scenarios, and suggest tools that might be interesting for you to use. So for example, now it's asking me if I want to replace this subassembly with something, open a copy of it, move it, or just open the reference. So I will open it. Here we can see that this consists of a little frame on the bottom that connects these parts or plants these parts onto it. You can see an electrical motor as well as some shafts connected to it. But there is nothing at the end of the shaft. The purpose of this part is to connect this motor to a water pump, and that pump will then be connected to the rest of the piping we saw in the other assembly. So we will have to make some of these pump parts. So I will go ahead and go to the first drawing I opened. And here we will then be creating our design. I'm going to start off simple. You can see we have the sketch tab. We will be starting off by creating a sketch that we can then extrude. The sketching tools are very simple to use. You can see we have some different options, such as different line options, singular lines, polylines, circles, and rectangles. For example, if I activate the polyline command, you can see I can just start drawing in the model space. If I select the rectangle, I can just immediately draw a rectangle, and you can see I have some different adaptive inputs in terms of the dimensions of this. So I can give it specific values, for example, 200 by 100 millimeters. And you can see if I hover over it, the quad will detect that I have selected a polyline. It will ask me and give me some different suggestions for what tools I can use. Also, if none of the tools on the top here are suited to what I want to do next, I can always go to these sub-tabs where I have a wider range of different options, for example, offset. so I can immediately get the chance to offset this rectangle just by hovering over my model. So you can access these tools from the ribbon, you can access them from the quad as well, or if you want to, you can also use the command line at the bottom of my screen. You can see here, this is compatible with a wide range of commands. Everything you see in the ribbon can also be called with the quad or command line. So for example, the circle command, I can just type circle into the command line. You can see the command dialog going on down here, and I can start drawing a circle from here. So we allow you to use whatever approach that you are most comfortable with. You can use the quads, you can turn off the quad if you want, you can turn off the ribbon if you want, you can turn off the command line if you want. You can change the interface as you wish. For example, if the command line is too large and you want a bit of more minimalistic look, which I prefer, you can just activate a floating command line, making it a bit smaller. But so, with that out of the way, let us get started with some of the modeling we will be doing to create these pump parts. First of all, I will start by creating some circles. These circles I will use to extrude and create a solid to represent the main body of my part. And we'll create one more circle there. I will now extrude the outer circle to create a solid body, very easily using the quad. And right now I already have a 3D solid. I can use the other two circles as cross sections to create a lofted 3D solid. So you can see if I activate the loft tool, select the two circles, it will generate a 3D solid between them. Now I want to add some more details to it on the top to be specific. We can keep adding on sketches and extruding them, but I can also just immediately use a 3D solid, such as a cone features, as you can see here. I can define to have a flat top on top as well, and I can define a radius, a height, like so, and extrude this one a bit further. I can do the same with the front part actually, like so. And now the next step will be to connect the top part to a seamless or smooth transition to the main part of the solid. So I will have offset the outer edge of it inwards, and I will create this line to create an intersection point. If I select these two lines, you will see that. I can then create a radius between the top part here, which I want the transition to move from, and then snap the end of the arc to this intersection. Define a radius for it. And might be difficult to see, so I can select them for you to see better. Now I can use this, first I will offset this circular edge a little bit and use this circle as a profile to sweep along the arc I just created. So here I can select the path I want to sweep, and there we go. I can select this 3D solid and I can move it into the housing of this pump part, like so. And here we already have quite a smooth transition from this top part into the main housing. We can delete the sketches because we don't need them anymore. Down here we can see there's a bit of a harsh transition, so I can pull this face downwards by, let's say, 10 millimeters maybe. And then we have a lot more of a smooth connection here. Now we can start rounding off some edges. So for example, on the front face here, I can add a fillet to give it a radius. And now this part is a complete solid. It's completely solid, so I will hollow it out on the inside. Then I will make some cutouts on these flanges or these end sections. I will extrude it inwards. I will do the same on the top. Like so. And now we can see eventually that the part will be hollow on the inside. I will just do the back as well. Like so. You can see that it has been hollowed out on the inside. Now this flange will be used to connect it to another part, so we will make it a bit thicker, 20 millimeters thicker. Then we can use this for some bolted connections later on. We will add a bit of a lip on this edge as well, so I'll offset this 5 millimeters, extrude it inwards a bit, like so. On the top, we will see that there's a bit of a harsh connection here, so we can change the diameter here. We can now use this edge to add a chamfer to it, making a bit more of a seamless transition. Let's say 15 millimeters. This top face we can delete to make the chamfer complete, and the remaining edge we can add a fillet to. Like that. This now is a lot more of a smooth transition for the water to flow, as this will be a water pump. And this now will be the main 3D solid, the basic shape of our pump casing. Now this part is very much a simple 3D solid still, but we can add some more information to it before we use it in an assembly context. We want a bolted connection on the back part of it, so we can then make some hole connections here. We have a library panel where we can easily just click and drag and place a hole into here. We can then in the mechanical browser already see that it's fully parametric, and we can change the diameter and depth and so on of it. This can also be changed at a later date. So if the design actually changes, then we can keep changing it. We can also make an array of it, like so. The whole array will also be parametric, so we can see the different settings of it. We can change the hole count, for example, from 6 to 8 holes. And it can also be changed. The rotation of it can also be changed, so you can still use the same principles of direct modeling to change this about the part. We also want a bolted connection on the top and the front here, so we can once again use the library panel to use some standard features, so we don't have to use it or make things from scratch. You can search through the different flanges, or you can also search for a flange if you know what you want to use. You can just click and drag it into the model space. Here you can then change the values before placing it or after placing it. I want to place this on the front face, so I will do it like so and snap to the center. Same principle on the top. Just like this. And very quickly, we have some standard features automatically applied to the model, as well as a parametric hole feature on the back. So this way, we believe that we can use the power of direct modeling, having a lot of freedom in your designs, as well as using the approach of applying parametrics to be able to create intelligent design. This is what we call variational modeling, as you will be free of history, tree corruptions, and so on. And it is a very intuitive way to work with a design. We can still apply some mechanical information to this. So in the top here, I can give this a name case. We can change some different parameters of this part. So we can change how it will appear in the bill of materials. We can also give it a material. So let us give it a material. Here we have a library of parts that we can select from, or library of materials. We can apply, for example, the basic steel material. You can see the identity of it, a name. You can see the density of it, which will be used to calculate a weight for the part. Or you can also create your own materials as well. We can also use the newly introduced feature of adding custom properties. So we can add a property set. For example, we can add the property set called manufacturing information. We can give this a property, for example, part number, or we can give it the value cost if we wish to order it. We can also change or set a different property set. So for example, surface treatment. We can give the surface treatment its own property, for example, painted. And here we can give it different enums. So we can give it predefined values. I can add one for, let's say, red paint or blue paint. If I select OK now, we can see on the bottom of the mechanical browser, we now have the custom properties for manufacturing information. So I can give it a part number, I can give it a cost, and I can select between the predefined values of the paint color as well. So manufacturing number, I can give it, or part number, I can give it just a randomized number. And all of these values, whatever you fill in, can then be retrieved in the bill of materials later on. So I will save the part, and I will go into the other parts that we looked at earlier, and we can now use this part in an assembly context. So in this part that we looked at earlier, we can then start to insert the part we have created. There's also some other parts we need to insert, but they have been also made in advance, just for the sake of time, of course. So we will locate these through the folder browser here. We can select the part we want to insert. It will hover into the model space, and we can just click to place it. We can also then move these into place and constrain them into place. I'm going to rotate this part so it's more aligned with how I want to place it. I will place my manipulator in this radius here so I can align it and place it on the holes that we can already see on the plate here. And I will then move it into the correct location. So I positioned it correctly with the holes on the other side, but we can see here it didn't fit. While here it does fit, meaning the hole pattern is not correct according to the part we have. So I now placed the actual part in the middle, and we can actually now go ahead and edit the bottom plate in place. So here I can select the two holes. I can then move them upwards by 5 millimeters, which seems to be good. I will do the same for the other holes. And like this, I can edit the subpart even in the assembly context. I don't have to open it separately to do this. So I always know that the changes I make will actually fit with the rest of the assembly as well. And then I can just go ahead and place bolts here as well. We can place new bolts from the library panel, but since we already have some bolted connections that can be used here, I will just copy them for the same purpose. So I will copy it to this hole. Then I will copy both of these to the other side of the part as well. Like that. And then we can go ahead and insert some of the other parts that we have pre-made. You can see them here. You can also see a preview, so that makes it easy for us to see what we are inserting. First of all, I will rotate this part so that it's angled how it should be in comparison to the rest of the assembly. Then I can apply some constraints to put it into place. The constraints I'm using are the coincident constraint, making two faces touch each other, and the concentric constraint, making two axes or two cylindrical surfaces share the same center. So like here, I can select this cylindrical face, and make them share the same center. Then connect that face with this face. And like that, we already have these parts assembled. Now, the only part remaining is our case that we created earlier. I will rotate this into a more appropriate position as well. And just like the other parts, I can very easily use the coincident constraint between these faces and use the concentric constraint between these faces. And now it is placed correctly. Of course, we need to add some bolts still to this. We can use, again, the library panel for this. Just searching what we want, clicking it, dragging it into the model space. We can change the size of it to something that will fit the model more. I'm looking for M16 times 2 with 40 in length. Like so, and I can snap this onto the center of this hole here. Like so. Of course, we need more of them. So like with the hole itself, we can also make an array. I will select to choose an axis or a line to create the array around. So I'm going to draw a line here. And here it has created an array. You can see it doesn't line up perfectly with what we have before. So we can go ahead and change the amount of bolts like we did previously to 8 bolts. And like that, we can see it fits perfectly. So like this, we were able to very easily constrain these parts that we had made to complete the assembly. Now that we have this assembly, of course, we want to retrieve some of the information on each of the parts, so we can then generate a bill of materials. I will generate one from the bottom level, meaning that all of the parts in this assembly will be highlighted. Here we can see that we have a number for each of the parts, component name, a quantity for each, and we can add new columns such as the physical material, the mass. For example, for the quantity, we can also add a footer to summarize all of the parts. You can see that now we have 63 parts total. And likewise, we can also add a summarization for the weight of each part, and we can see the total weight as well. Here in the drop-down menu, you can see where I placed the previous columns from. You have a lot of columns to choose from. For example, the part number, which I added earlier, just as an example, you can see I can add it here, and I can see the number that I gave to the case for the pump previously. You can also add a column to see if the parts are standard or not. So for example, The bolts, or washers, if we select them in the bill of materials, we can also see them highlighted in the model space. So we get a good overview of what parts should be ordered, what parts should be made, and so on. Here you can see an overview of the menu where you can create new menus. You can also save the current configuration to a template as well if you want to reuse the editing you have done to the bill of materials. So now that we have the bill of materials, we of course should use this to convey the manufacturing information. Generally, this is done through a drawing. So I will go to the layout tabs on the bottom of my screen here. Here you can see we have an empty drawing, and we can also change the configuration and the setup of this drawing. So here we can change what kind of printing style we want, what paper sheet size we want. Here I set it to an A3 size. And if I go back to the model space, I can generate drawing views from this 3D model. Now then I can see this preview of my part. I can select some different views. And when I hit enter, it will start generating these views and turning them into 2D geometries in a sense. I can change the scale of the drawings as well to a standard scale. I can also insert a bill of materials. And if some of the views don't fit together perfectly, you can see there is some overlap now. I can still move them around and change the setup of my drawing. Some of the rectangles around the views are overlapping, but these are just there to indicate the size of the viewport. They can be turned off at a later point, so I'm not going to worry too much about them. So here we can see we have the bill of materials. I can use this now to place balloons on my model. So by selecting Balloon Auto, selecting the view, I can then automatically place this string of balloons indicating the different parts and their numbering in relation to the bill of materials. They can also be placed manually, of course. But we can also place some dimensions. First, I'm going to place some center points for these holes. As this will be mounted onto another part of a larger assembly, I will give it the measurements for this hole pattern. So the person doing the installation will know how large it should be. I will also add some dimensions for the general size of the part so that they have an indication of how much space it will take up in the larger assembly. Of course, if you have a part drawing, you might want to have more specific, more detailed dimensions as well, which of course is possible. And you can also place tolerances as well on these drawings. Here I will just change the value of this. This value is not that important, so I'm going to change the decimal points to a more rounded number. So here we can see a basic drawing generated from these models that we have looked at today. And this is about all I wanted to show in this short amount of time. Of course, there is a lot more that can be said and shown in regards to BricsCAD Mechanical. This is only scratching the surface, but I hope this has given you a good taste of what can be found here. It might already be a lot of information if you're not familiar with Mechanical CAD or BricsCAD. So just to recap, BricsCAD Mechanical offers the license for 2D drafting in Light and 3D modeling in Pro, and will let you sketch and model your designs. But the mechanical aspect of it then expands on this by allowing you to create assemblies, assign mechanical information, generate bill of materials, and create manufacturing drawings. A standard part library and tool sets for modeling in specific contexts like sheet metal and piping is also included. So with that, thank you for your attention. I hope you liked this and learned something from it. And with that, I will give the final words to Jazz.
Thanks, Frederick. Absolutely amazing demonstration. And one thing you didn't see, folks, purely because of time, is the sheet metal functionality. If you take a deep dive, if you're using any fabrication, any sheet metal fabrication in your business, you really, really want to check that out, because a couple of clicks, you got from your profile to a 3D, straight to a 2D, straight to manufacture for production. Absolutely fabulous. Right then, folks, thanks for that, Frederick. Let's now move on to, as you know, part of this webinar series, we like to share customer stories. So this particular customer is a BricsCAD Mechanical customer, and here they are. They're an Astro shipyard based in the Netherlands, and they construct, maintain, and repair inland shipping vessels, offering complete solution from design to delivery for clients such as shipping companies, government departments, and even private individuals as well. And they use BricsCAD Mechanical. They've incorporated all 3D modeling with BricsCAD into the design workflow. They have found this to be very helpful, and it's to complete their innovation and accuracy in the design process. And they found BricsCAD Mechanical to be the perfect solution for their needs, as well as being much more cost effective than the previous mechanical design products and the other CAD products they had in the business. It's enable them to achieve faster, more effective workflows, and they're able to easily use complex 2D drawings and 3D multi-CAD data in formats such as IPT and step files as well. So again, it's a great little story there. So just a very quick slide, and then it's all wrapped up for the mechanicals part. Folks, it is important to highlight that BricsCAD makes advanced mechanical design accessible. It is intelligent, flexible, affordable, and above all, enables greater design freedom, giving you 2D, 3D, and mechanical design, all in one application, DWG. Okay, and you compare that to what the price we mentioned of one particular vendor, just over $2,500 for a 3D application on subscription, and you can get ours on subscription just over £1,500, just over £800 and £1,500 for yours to keep. Really check out the website, check out that trial that's in the chat window. Really check that out. Thank you all for those questions. Right, back to this PowerPoint. Again, please keep the questions coming. I can see there's a flood of questions coming right at the end. It always happens right at the end. I love it. We've got the team here supporting you. I just want to leave you with, the flexible license options that are available. Those subscription perpetual options. You can choose as a single user, multi-user, stroke network. Those are yours. We're never going to change that. Okay. We don't tell you how to design. We're not going to tell you how to license it. That's for you to decide. So that's all available for you as well. And of course, it's going to be emotional. We've got our last session of the series on this Thursday, which we're finishing it all up with BricsCAD Ultimate. Full design cycle from start to finish in the Ultimate. So definitely check that one out if you if you haven't got that bookmarked in your diary or calendars, get that one in. It's going to be a good one. But folks, I would like to, on behalf of Frederick, myself, the whole BricsCAD team, I want to thank you. Thank you for your time, carving out this time to spend an hour with us, with unwrapping BricsCAD. And today was all about mechanical. And, if you're using 2D, 3D, mechanical design at your business today, you definitely want to look at BricsCAD. You really do. The flexible licensing, the competitive price tag that we're offering, it really is a deal not to be missed.